All right. So we have a graph up here because your mom had offered you a job at her office, $10 an hour. That's cool. You know, work during the summer. See if I can get a little extra cash to go to the movies or whatnot. But there's another option. Um, you can instead you decide that you could mow lawns and make $15 an hour, which is nice. But unfortunately, your family's lawnmower is busted, so you need to buy a new lawnmower first. And the one that's going to best help you out with your lawn mowing is going to cost $300. Okay? So let's make an equation for that. It's pretty similar. Let's make this one in black. So the amount of money you're going to make, whoops, not Y, M is going to be equal to $15 an hour this time. But you have to purchase a lawnmower, and that's going to cost you money. So you're going to start $300 in the hole because you have to purchase a lawnmower with your own money. Okay? And so we can graph this one as well. It's the same slope-intercept graphing, except instead of starting at 0, because if you work 0 hours in this case, you would actually make negative money because you bought something that never was used. So we're going to start out at negative 300. 1, 2, 3. So negative 300 is your starting point. And now it's a slope of 15 this time. 15 over 1. Let's write that down. Slope of 15 over 1. Again, let's make that a little larger because of our scale. So 150 over 10 works. So I'm going to go up 150. Actually, maybe that's not even the best way. What if I double that? Let's go by 300. So 300 over 20. That's nice. Okay. So I'm going to go up 300. 1, 2, 3, and then go over 20. I'm going to go up 300, 2, 3, and go over 20. Okay. And I'm going to go up 1, 2, 3, and go over 20. Then go up 1, 2, 3, and go over 20. Okay. So I'm going to connect all those. Try to get it as straight as I can. All right. Now again, I'm putting out the arrow on the bottom left, but that doesn't really make a ton of sense realistically because I'm not going to work negative hours. Now the negative money, that is realistic because that's money that you had to pay that you're not going to get back unless you actually work. So here we have this point of intersection. I'll circle it right here. It looks like it's at about 60 hours and $600. 60 hours and $600. That's supposed to be a comma right there. 60 hours and $600. And so you could say 60 comma 600. So what does that point mean in the real world in this scenario? Well, it means if you were to work 60 hours at your mom's office, you would make $600. On the other hand, if you were to work 60 hours mowing lawns, you'll also make $600. Okay, because even though you make more money mowing lawns, you had to make up that negative 300 that you started with. So why is this important? Well, it's important because if you can work more than 60 hours, it would probably be a good idea to mow lawns because then you'll have more money. For instance, if you worked for 70 hours, no, let's make it 100. If you worked for 100 hours at your mom's office, you would make $1,000. However, if you worked 100 hours mowing lawns, now you're making more money. Let's see. I'd have to plug it in because it's off the graph here, but you'd make $1,500, but you'd make $1,200. So you'd actually make $200 more during the summer working the same amount of hours. So it's important that we know this point of intersection or this break-even point so then you can make decisions based on it. So these decisions might work like, let's say you want to have fun during your summer vacation. So you only want to work 15 hours a week. So 15 hours a week. Okay, well, summer vacation's only so long. So if you only have a month of summer vacation, so let's make it even different. So let's say you have 3 weeks of summer vacation. Well, in that case, you only get a total of 45 hours of work. Okay. Well, if we locate that on the graph, about 45, that is somewhere around right here. If you went the lawnmower route, you would have made less money than if you went the office route. Okay. However, if your vacation is a lot longer, let's say, 30, 60, 90, if you can work for 7 weeks, now you're making more money mowing lawns. Okay, so it's important to know what point the break even is at 6,600 so you can make a decision based on that. Okay, so now you know the system of equation, how it works. In this chapter, we're actually going to learn several ways of solving systems. We're going to learn graphing. We're going to learn substitution. We're going to learn elimination. So this section is just on graphing. Now, a couple things can happen when you're making a graph. So let's see if we can get that out of the way in this same video here. So let me get a new. Let's get a new one of these. All right. So we talked earlier, when we have equations, a system of equations, and there's two equations, if they intersect, they have a solution. Okay? So this system has a solution right here. Okay, whatever that point happens to be. And we'll call this one solution. And it's right there. However, let's get a new one up here. It's possible for your system to come out with graphs that look like this. Let's see. Notice both of these equations have a slope of 1, and therefore they're never going to intersect. When this happens graphically with a system, we call that no solution, because there are no intersection points. No intersection points. No solution, no intersection points. The third thing that could happen when you're graphing, let's just go to a new page here. Is sometimes, let's just make one like this. This will have a slope of 2, let's say. Sometimes when you get your two equations and you graph them, you realize, wait a minute, it's the same equation. That's not perfect, but let's assume those were right on top of each other. In this case, we have the same equation with both equations that are given. Same equations, or equation, let's say. And so there is infinite solutions. Infinite solutions. Okay. Let me be a little more clear about what infinite solution means. For instance, a solution would be 1, 4, or 2, 6, or negative 1, 0, or negative 2, negative 2, and so on. There's an infinite amount. However, 4, negative 3 is not a solution. So notice the difference between infinite solutions and everything's a solution. Okay, so those are the three things that could happen. What I'd like you to do for homework is solve on page 415. Do number 1. And enjoy the rest of your evening.